Artificial intelligence. You hear that phrase, and it promises to change, well, pretty much everything. But here's the thing. Behind all that hype, there's this massive, kind of unspoken problem. Most AI projects are actually doomed to fail. So today, we're going to dig into why that is, and more importantly, we're going to uncover the blueprint for getting it right. From the very beginning, AI has been powered by this one huge question. What could we do, what could we accomplish if we could build machines that think? The dream was never really about replacing people. It was about empowering us. We want machines to help us get a better medical diagnosis, or make a city's power grid more reliable, or just get rid of those dull, repetitive tasks nobody wants to do. At their core, these are all deeply human goals. Okay, so to really get a handle on AI today, you have to know this one key distinction. On one side, you've got AGI. That's the sci-fi dream, right? A machine that can reason and create just like a human. It's the ultimate goal, but, and this is crucial, it does not exist yet. Everything we have today, every single AI application, is what we call narrow AI. These are specialist systems that are incredibly, unbelievably powerful at one specific task, like recognizing your face to unlock your phone or recommending your next movie. So how do these specialist AIs actually do what they do? Well, most of them follow this surprisingly simple three-step playbook. First up is perception. They have to sense the world, and they do that through data. Next is prediction. They use all that data to forecast what might happen next. And finally, there's planning, choosing the best possible action based on that prediction. Perception, prediction, planning. Those are the fundamental building blocks of almost everything we're going to talk about. So with those building blocks in mind, let's go ahead and open up the AI toolbox. This means we have to make a small but really crucial shift in how we think about this stuff. We've got to stop seeing AI as this single magical thing and start seeing it for what it is. A set of specific, specialized tools, where each one is designed for a very particular job. So just how many core tools are we talking about in this toolbox? Well, it turns out there are really just 7. Seriously. If you can get your head around these 7 patterns, from conversational AI and a chatbot, to recognition AI that unlocks your phone, all the way to an autonomous system like a Roomba vacuuming your floor, you can pretty much decode almost any AI application you see out in the world. But here's where the real magic happens. The mind-blowing power of AI isn't just using one of these tools by itself. Oh no, it's in combining them. Think about a factory robot. It's using an autonomous system just to move around. It's using recognition to see and identify objects. And it's using a goal-driven system to calculate the most efficient path to take. That's one machine seamlessly weaving together 3 different AI patterns to get the job done. Okay, so if the technology is so powerful and the tools in the toolbox are so clear, then why do so many AI projects fail? This brings us to a massive, kind of unspoken problem in the industry. A single, shocking number that represents billions of dollars in wasted time, money, and opportunity. 85%. Let that sink in for a second. According to industry analysts like Gartner, that's the percentage of AI projects that fail to deliver on their promises. 85%. They just don't generate the savings, or find the insights, or create the efficiencies they were built for. So why? What is going on here? What's behind this staggering failure rate? Now, you might assume the technology itself is to blame, but that's actually rarely the case. The AI can be totally groundbreaking. The data scientists can be brilliant. The failure almost every single time comes down to the process, a failure to use a roadmap that's actually built for the unique challenges of AI. The first major reason for failure, it all comes down to one thing: data. And here's a statistic that really reveals the hard work behind AI. A staggering 80% of the effort in any given project isn't spent on the cool, fancy algorithms. Nope. It's spent on just getting the data ready, cleaning it, labeling it, and preparing it. It's not the glamorous part of AI, but it is the absolute foundation. And this whole reality is captured perfectly in one of the oldest sayings in tech, which has never been more true than it is today in the age of AI. Garbage in, garbage out. An AI model is only as smart as the data you train it on. So if you feed it messy, biased, or just plain incorrect data, you are absolutely guaranteed to get garbage results on the other side. It really is that simple. But hey, even if you have perfect data, there's another huge pitfall where projects just fall apart. And that's the gap between the clean, sterile lab and, well, messy reality. You can build a model that's 99% accurate in a controlled environment, only to watch it completely collapse when it faces the unpredictable chaos of the real world. For a perfect, if kind of painful, real-world example, you just have to look at Japan's Henna, or Strange, hotel. The big idea was awesome: staff the entire hotel with robots for a futuristic, super efficient experience. But the reality, well, the in-room assistants started mistaking snoring for commands and would wake guests up all night. The bellhop robots couldn't even navigate the hallways. The result? The world's most efficient hotel had to lay off more than half of its robot staff because they were just creating more work than they saved. It's a perfect lesson in that lab-to-reality gap. So, if the technology isn't the problem, but the process is clearly broken, what's the solution? Well, we need a smarter approach. We need a methodology that's built from the ground up for the data-first challenges that are completely unique to AI. And that framework actually exists. It's called CPMI, which stands for Cognitive Project Management for AI. The best way to think about it is like a roadmap that takes all the best parts of modern software development, that iterative, flexible spirit, but then rebuilds it around the core phases of a data project. And the logic of these phases directly addresses every single failure point we've just talked about. I mean, look at it. It forces you to understand the business problem and your data before you're allowed to write a single line of code. It dedicates entire phases to data prep, to model development, and this part is so crucial, to model evaluation, so you can test everything against the real world. It's a true end-to-end roadmap for success. And while we're on this topic, let's just quickly clear up a common point of confusion: the difference between an algorithm and a model. People use them interchangeably all the time, but they're not the same thing. Here's the easiest way to remember it. The algorithm is the recipe. It's the general set of instructions. The model is the finished cake. It's the specific results you get by applying that recipe to your unique ingredients, which in this case is your data. This entire philosophy, this whole CPMAI approach, can really be summed up in one powerful mantra: think big, start small, iterate often. Seriously, this should be on the wall of every single AI team. You don't try to boil the ocean and build the world-conquering AI on day one. You have the big vision, sure, but you start with one small, solvable piece of the puzzle. Get it working, learn from it, and then iterate, improve, and expand from there. So you've used the right process, you've started small, and congratulations, you've successfully deployed a model into the real world. Job done, right? You can pack up and go home? Not so fast. An AI project is never really finished. Now the long haul begins, keeping your model alive and effective in a world that is constantly changing. You see, every single AI model eventually faces this inevitable challenge called drift. There are two main types. First, there's model drift. That's where the model's performance just naturally decays over time, kind of like a star athlete's skills declining over a long season. Then there's data drift. This is where the real world changes so much that the model is basically using an old playbook for a brand new game. The world is always changing, so your model has to change with it. So, how in the world do you fight drift? Well, you do it with a discipline called MLOps, or machine learning operations. It's all about managing the entire lifecycle of a model after it's been built. It has two key parts. You've got the basic plumbing of just deploying the software, and then you have the ongoing AI health check that's constantly monitoring performance and retraining the model to keep it sharp and valuable. And finally, we have to talk about this. Technical success alone is not enough. For AI to have a lasting positive impact, it has to be built on a foundation of trust. This means we have to create systems that are more than just accurate. They need to be transparent so we can see how they work. They need to be explainable so we can understand why they make a certain decision. And they have to be governed so there's clear accountability. These aren't just buzzwords. They are the absolute essential pillars of responsible AI. Which brings us right back to where we started. The big conversation we should all be having. It isn't really about whether machines are going to get smarter than us. The much more interesting and I think much more important question we all need to be asking is this: as machines get smarter, how will we get smarter with them?